Well, students, as you can see the question says that 100 identical coins, each with probability P of showing up heads, are tossed once. If P is an open interval of 0 and 1 and the probability of heads showing on 50 coins is equal to the probability of head showing on 51 coins, find the value of P. Well, we have read the question, and the question is talking about that if P is that probability of each coin which can show up head, then if 100 coins are tossed once, they are tossed once, it is not one by one, once. And if the probability of 50 coins is equal to the probability of showing head on 51 coins, what is the value of P? So, well, the question is clearly talking about BPD. Why BPD? Because heads, if you are not getting heads, then you will get tail. So, probability of failure and success is 1. And they are independent. They are with the replacement. So, that's why the question clearly is of binomial probability distribution, which is BPD, binomial probability distribution. And the binomial probability distribution says that it is Q plus P whole raised to power n, where n is the total number of trials, and its general term indicates where Q is the failure and P is the success. So our target is to find this P. So what you can do is find the probability of 50 coins and put that equal to the probability of 51 coins. After a bit of cancellations, we can surely find the answer. So let's begin. Well, we all know that n is 100, and in one case r is 50, P remains same, and Q is either Q, or later we can take that as 1 minus P, because the target is to find the value of P. Using NCR, Q raised to power n minus r, P raised to power r. And in this case, both will be 50 because 100 minus 50 is 50. Now, in the second case, n is 100, r is 51 because there are 51 successes, P remains same, Q will be Q, and later we'll convert that Q to 1 minus P. Remember, this is 49 now, 100 minus 51, and this is P raised to power 51. Now, according to the given condition, so we're putting them equal. Now, we can cancel this P50, and we'll be left with only P raised to power 1, and this will not be taken as root loss because P cannot be equal to 0. Similarly, we can cancel Q to the power 49 with Q to the power 50, and we'll be left with Q to the power 1. And this again will not be a root loss because Q can never be equal to 0. So with the remaining expression, we proceed. So we have So I'm doing the calculation for 50. So I'm doing the calculation for 100C51 divided by 100C50. Straight on, this 100 factorial will be cancelled. And now this 51 factorial can be written as 1 upon 51 into 50 factorial. This 49 factorial remains the same, and this denominator's denominator, this 50 factorial remains the same, whereas the other 50 factorial becomes 50 into 49 factorial. So you can see that many terms are cancelled, and we are left with 1 upon 51 into 1 upon 1 upon 50, which in terms be 50 by 51. So putting this value here, we have 50 over 51. This is the time where we'll write Q as 1 minus P upon P, because the target is to find P. And by simply cross multiplying and shifting, and now we can find the value of P, which is 51 over 101. Remember, the unknown should always be on the left hand side and the number should always be on the right hand side. Thank you very much.